A Galilean thermometer consists of a closed glass cylinder containing a liquid. In the liquid there are several identical sealed glass bulbs, as shown. Attached to each bulb is a metal disc labeled with a temperature. Each disc has a different mass. As the temperature increases, the density of the liquid decreases. This causes the bulbs to move within the liquid. Okay. So explain why a particular bulb will float until the temperature of the liquid exceeds a certain value. After the answer, I have added a note and I said there, even though the question says will float, it appears from this question and the way it's phrased as if it will start floating. No. That's not the question, man. The question says it will keep on floating. So how can I construct the answer? Upthrust on a bulb is equal to the weight of the liquid displaced. Once it's floating, as long as it's floating, upthrust is equal to the weight. When the upthrust exceeds the weight of the bulb floats. Doesn't have to exceed, upthrust can be equal to the weight of the bulb as well. But here's the thing, weight of the bulb is constant. As temperature increases, the density decreases and the upthrust on the bulb will decrease until the weight of the bulb exceeds the upthrust, or in other words, until the upthrust becomes smaller than the weight. Weight remaining constant, as temperature changes, the upthrust changes, and if the upthrust becomes smaller, there is a resultant force on the bulb. Why? Because upthrust is smaller, weight is greater, now there is a resultant force. Why did I not bring in drag anywhere? Because all throughout the bulb was stationary. You bring in drag only and only when something starts moving in a fluid. Since the bulb was stationary, you don't have to bring in drag at all. So look at the keyword in the question. I already mentioned this previously. The question says will float. What they actually meant was it will keep on floating.